In the previous module, we have mentioned one of the landmark results of social choice theory known as the arrow's impossibility result. What does this result say? It says that if you have 3 or more alternatives, then if an Arrowian social welfare function f satisfies 2 very desirable properties, weak Pareto and independence of irrelevant alternatives. Remember what was weak Pareto? It says that if you have any 2 arbitrary alternatives A and B, and if everybody prefers A over B, then the social ordering should also maintain that order. That is weak Pareto. Independence of irrelevant alternatives says that if you have 2 preference profiles R and R prime, where the relative positions of A and B are the same. So A and B again are 2 arbitrary alternatives. Their relative positions, so player 1 has A above B, player 2 has B above A, and player 3 may have A and B to be at the same level, and the same ordering is between A and B is holding true for for R and R prime, 2 different preference profiles. Then the social ordering FR and FR prime should maintain the same order over A and B. So if in FR A is above B, it should not happen that B comes above A in FR prime, right? So that is one of the requirements of IIA. So with these 2 properties, the arrow's impossibility result says that you cannot have any social welfare function other than the dictatorship. That is the impossibility result. So in this module, we are going to prove this result. One of the reasons of proving this is because there are some interesting proof techniques that we'll be using later on in this course. So in order to proceed with the proof, we need to define this notion of decisiveness. Informally, the notion of decisiveness says that a player who is a player or a group of players who are decisive over the all pair of alternatives. So if they think that A is above B, then that A above B will also show up in the social outcome, the F of R, right? So that is the notion of decisiveness. So formally, what we can say is, suppose we have a social welfare function F, and we have a group of players, non-empty group of players, which is a subset of N, and we call that G is almost decisive over A comma B to a pair of alternatives. If the following thing happens, whenever A is strictly preferred over B for all the players in G, so let's consider, so we can partition this set of players in G, and the other part is N minus G. So for all the players here, A is strictly preferred over B. They all prefer A strictly above B. And for all the other players, B is strictly preferred over A. And the notion of almost decisiveness says, whenever this property is satisfied, the outcome should always, so let's call that this preference profile is R, then F of R should have A strictly above B. This is what the notion of almost decisiveness means. Now we will use this shorthand D upper bar G of A comma B to denote that G is almost decisive over A comma B with respect to the social welfare function F. So that is kind of hidden in this notation, but that is understood because we are only talking about a specific social welfare function. Now, what is the definition of decisiveness? So it is just taking out this condition. So it is saying that as long as G has A strictly above B, the outcome should also have A over B. I don't really care whether B is strictly above A or not for the players who are not in this set G, right? So we will also write this the shorthand dg of A comma B to denote that G is decisive over A comma B with respect to F. And it is not difficult to see that this implication holds. So whenever a particular group is decisive, it is also almost decisive. And why is that true? Because in the condition, in the if condition of almost decisiveness, we are actually using a much stronger or more restrictive condition. So if this A is strictly above B and B is strictly above A, then only you have this f of r having A strictly above B. While for the decisiveness, you don't really need this second condition. So in that sense, it is relaxing it the if condition a little bit. Therefore, the notion of decisiveness, the whole property of decisiveness is more restrictive. So if you want to directly prove that decisiveness implies almost decisiveness, here is the way to go about it. So you already know that this G is decisive. You'll have to prove that this is almost decisive. The if condition already gives you this property that the A is strictly preferred over B and B is strictly preferred over A, but you don't really need this condition. The moment A is above B, you know by decisiveness the outcome should have A strictly above B. So this condition will hold. So whenever it is decisive, it is definitely going to be almost decisive. So these two properties will be used for proving the arrow's impossibility result. And we will prove this result in two parts. The first part, field expansion lemma. What does this mean? It says that if a group, let's say G, is decisive over a pair of alternatives, then it is decisive over all pairs of alternatives. So this is the notion of field expansion. A group who is deciding between A and B, then you can actually say that that group G is going to be the deciding factor for all pairs of alternatives. In some sense, they are kind of dictating the outcome of the social welfare function. On the other hand, the part 2 is essentially a lemma which is called the group contraction lemma. It says that whenever you have a decisive group, let's say G, then you can find a strict subset of that group which is also decisive. Now you can just keep on applying this group contraction lemma multiple times until you get just one element or one player. So the final group will be just consisting of one player whom we will call the dictator. And now you can see that if we can prove these two lemmas, the proof of arrow's impossibility result will be immediately completed. So let us go over this one by one. So first is the field expansion lemma. So to make it more formal, let us write it in the following way. So suppose we have a social welfare function which satisfies this weak Pareto and IIA properties. Then you pick any 4 alternatives, A, B, X and Y, and a group which is a non-empty subset of n, and A is certainly not equal to B and X is not equal to Y. If G is almost decisive over A comma B, then it implies that it is going to be decisive over X comma Y. So this is a very strong implication. It is saying that if you just be not even decisive, it's a weaker notion, almost decisive, over any two alternatives A and B, then you can have the decisiveness over all possible other alternatives X comma Y. The only condition that is going to get satisfied is that A should not be equal to B and X should not be equal to Y. Now, so let me also remark that under this condition, even though we have seen that decisiveness is stronger property than almost decisiveness, this particular result, field expansion lemma, is saying that under this weak Pareto and independence of irrelevant alternatives, these two notions are identical, because you can also replace X and Y with A and B itself, and it says that almost decisive in this case is also giving you decisiveness, right? So we'll prove this by exhaustively listing down all the cases that we need to consider. And we list this down just to make sure that we don't leave out any of the possibilities, but we will just show that if we prove two cases, the other conditions, the other cases can be proved using those two cases in a clever manner. So X and Y are arbitrarily picked, so X and Y can take any values. So in particular, both X and Y need not be equal to A and B, that is one condition. X can be equal to A, but Y need not be equal to A comma B. So this is the other condition. X can be equal to B and Y need not be equal to A comma B, any of them. Now come to Y. So Y can be equal to A and X is not equal to A or B, and Y can be equal to B. X need not be equal to A comma B. And the other two conditions is where X is equal to A and Y is equal to B, and the other way around. So X is equal to B and Y is equal to A. So if you look at the 7 conditions, they are exhaustively listing down all possible cases. So these are the this is the exhaustive listing. We have just written it in this order so that it gives us some help while we prove these results. We can use the cases 1 and 2 in the rest of the proofs in proving the other cases. So let us focus on case 1. So what is needed to be proved here? We will have to prove that if this group G is almost decisive over A comma B, so left hand side is always the same, then that group is decisive over A comma Y, which means that Y can be taking any value except A and B. So now let us look at what does this particular condition mean. Whenever A is strictly preferred over Y for all the players that are in this group G, we'll have to show that the social ordering also maintains that order. That is the definition of DG A comma Y, decisiveness property between A and Y. So in order to do that, let us construct a different preference profile R prime, and here we partition this into two parts. One is the G part and one is the N minus G part. So this distinguished group G, and the way we have we keep this is that we have A strictly above B and B is strictly above Y. So this is the composition of the group G. And in the group N minus G, we have created this particular ordering, that is B is strictly above A and B is also strictly above Y. But we do not say anything between A and Y. We are going to set that according to what Ri had. So we know that A is going to be strictly above Y, because that is the given condition in R. So in R also, for all the agents in G, A is going to be strictly above Y. So that is already maintained even in R prime. And in the other part, that is in N minus G, the if condition of this DGAY is not saying anything. So therefore, in those cases, we are going to maintain the ordering between A and Y to be the same as the ordering of R of I. So if let's say for some player here A is above Y, we are going to maintain the same order in R prime for that between A and Y. And if the other way around is true, then we'll maintain that order. Ordering is the same as the ordering of Ri, right? So that is something that we are going to ensure. So while constructing this profile R prime, we are ensuring that Ri prime restricted to A comma Y is the same as Ri restricted to A comma Y. Now we are given that group G is almost decisive over A comma B. Now notice that we have constructed R prime in the following way, that on G it is all the players are preferring A over B, and outside it everybody prefers B over A. So almost decisiveness will immediately imply that A is strictly above B in if R prime. Now we apply the property that this is weakly Pareto over B comma Y. Weakly Pareto says that if you have a pair of alternatives, in this case B and Y, where every individual in this profile prefers B over Y, then that means that in the final outcome B should also be strictly above Y. So now using these two properties together, we can use transitivity. A is strictly preferred over B, B is strictly preferred over Y, then A must be strictly preferred over Y. This is coming because of the transitivity of Fr prime, because this is a ordering after all. Now we know that R, so between A and Y, the ordering of all the players in N is identical. So since A is strictly preferred over Y in R prime, that implies by IIA that A must be strictly preferred over Y. And that is all we wanted to prove. We started with the fact that A is strictly preferred over Y for only the individuals who are in this group G, and we wanted to prove that A is strictly preferred over Y even for the social outcome, and that is what we have proved. So therefore G is decisive over A comma Y. So this is the first property that the first case that we have considered. The second case is, the left hand side is the same, that G is almost decisive over A and B. Now we'll have to show that G is decisive over X comma B. Again we pick the if condition of this DG X comma B. So it says that if you pick an arbitrary R such that X is strictly preferred over B for all I in G, we'll have to show that X is strictly preferred over B even in the aggregated profile F of R. How do we show that? We again construct an R prime where we keep it in the following way. So we have X strictly preferred over A, X is strictly preferred over A, and A is strictly preferred over B on this group G, and in the group which lies outside this, X is strictly preferred over A and B is also strictly preferred over A, but the relative ranking of X and B is with respect to R itself. So we are going to maintain the relative positions, the ordering of X and B identical to R of I for all the players I in N. Right? So this is the same thing that we had done in the previous case. So this is entirely possible because by the given condition of R, we know that X is strictly preferred over B, which is maintained here in G. For the rest of the things, we have constructed it in such a way that X and B's relative position is maintained. So this is entirely doable. Now we apply the following thing, that G is almost decisive between A and B. So what does that mean? That whenever you have A and B to be, so on this group G, A is strictly preferred over B, and outside this group B is strictly preferred over A. So almost decisiveness will immediately give us that A is strictly preferred over B, because G is almost decisive over A and B. So this happens for R prime. And then we know that weak Pareto, we know that by the way of constructing it, X is strictly above A for all the agents in this profile R prime. Then weak Pareto will tell me that X is strictly better than A even in the social outcome F of R prime. Now again apply the transitivity between this using these two properties. We will get X is strictly preferred over B in the social outcome F of R prime. Now R prime and R maintain the same relative ordering between X and B, and because X is strictly preferred over B in this case, IIA should imply that X must be above B even in R. So that essentially proves that G is decisive between X and B. So this proves case 2. Now the rest of the case essentially depends on these two cases that we have just proved. It is easy to see that when we have almost decisiveness, G is almost decisive between A and B, then by case 1 we have already shown that it is decisive over A comma Y, and by the definition of decisiveness it is almost decisive over A comma Y. And now we can see that A comma Y, so now we apply this case 2. So notice that in case 1 the first alternative remains the same and the second alternative changes as long as this second alternative is neither A or B, which is the case here as well. But in case 2 the second alternative remains the same and the first alternative changes as long as this X is neither A nor Y. This is fine. So this we can conclude from case 2, and that will give us this is decisive over X comma Y, where X and Y none of them are equal to A comma B. So this proves case 3. Similarly for case 2 you can write this implication using case 2, which we have already proved. Then this part comes via definition. and the last one comes from case 1. So similarly, so I am not going into the all the details of this proof, because they are kind of repetitive and they are doing the same, using the same ideas over and over again. You can take a look at this closely and find out that this is actually proving, this is reusing the cases and the definition appropriately and showing the same result. So this proves the first part, that is the field expansion lemma. So if you have a group which is decisive over any pair of alternatives A and B, almost decisive, then it is decisive over all possible pairs of alternatives. So this is a really very remarkable. So let us now look at the other part of this proof, which is the group contraction lemma. Now the formal statement is the following. So again, let us assume that F satisfies these two properties, and we consider is a group, a subset of N, which is non-empty and has at least two agents, right? So if there is only one agent, then we have nothing to prove. So we have a group which is whose size is at least 2, and that is a decisive group. Then what we are going to prove is that there exists a strict subset of this G, which is also non-empty, and that is also a decisive group. So how should we prove this? Now let us partition the groups in the following way. So the group that we are given is this G, and we are constructing two strict subsets of this group, G1 and G2, in the following way. And we also consider a specific preference profile, which is denoted by R. We'll see that because of the field expansion lemma, even if we prove it for a specific preference profile R, this can be used for any preference profile. So it does not really matter. This R is chosen carefully such that we can prove the following results. So what happens on G1? So this is these two things together is actually our G. So we have partitioned it in this way. On G1, everybody has this preference. A is above B is above C. And in G2, C is above A and A is above B. And for all the agents which are outside G, so B is above C and C is above A. Now we see that if you look at A and B together, A and B, A is strictly preferred over B for all the individuals in G. And we know that G is a decisive group, and therefore A is going to be above B even in the social outcome F of R. So this is the first observation that we can make. Now let us consider two cases. There can be only two cases. Either A is strictly preferred over C, or A is not strictly preferred over C. So that's the second case, which we will consider next. Now when considering this first case, let us also look at G1. So we look at G1 and we see that A is strictly preferred over C for all the players in this group G1, and what we can see is C is above A in all the other groups. So whenever the player is not in G1, C is strictly preferred over A. Now if we consider all possible R primes, right, where this particular relative ranking between A and C holds, then using IIA we can say that for that A should be strictly preferred over C for all those A primes. So this actually says that this group G1, so this should be actually G1, so this is almost decisive between these two alternatives A and C. So just think about this carefully. We have in all those preferences, including R and R prime, in all those preferences A is strictly preferred over C for all the elements in G1, and for all the other elements C is strictly preferred over A. And we have just shown that for all those preference profiles, A must be strictly preferred over C. So that is the definition of almost decisiveness. So G1 is almost decisive between A and C. And now we can apply the field expansion lemma and say that G1 is now decisive over any pair of alternatives. So this is one part. So if this condition holds, one of these two conditions, then we have shown that this part G1 is decisive. Now in the case 2, we'll show that G2 is decisive. So how should we show that? So let's look at this. So this is the case where A is not strictly preferred over C. That means C is at least as preferred as A. Now from 1, so if we go back to the first condition, because G was decisive, we knew that A is strictly preferred over B. Now A is strictly preferred over B, and the fact that C is at least as preferred as A, using transitivity we can see that C is strictly preferred over B. Now we can consider this G2. Now we can see between C and B. So let us consider C and B. So you see that in G2 C is above B, and everywhere outside G2 B is above C, right? So this is exactly the similar condition as G1 for A and C. So this holds, and we know that for all those conditions, so C should be strictly preferred over B, right? So that is the condition that we have found here. Now therefore, if we just use IIA as before, consider all possible R primes for which this condition holds, then we can see that the G2 becomes almost decisive between these alternatives B and C, and using field expansion lemma we can say that G2 is decisive for all pairs of alternatives. So what we have just shown is that we have partitioned G into two non-empty subsets, strict subsets. In case 1, G1 becomes the decisive set, or in case 2, G2 becomes the decisive set. So whenever G is decisive, there exists some strict subset of it which is decisive. So therefore we can always prune any decisive set G to get an element which is small enough. We can reduce it to one element set which is decisive, and one element being decisive means that is the dictator, and that essentially concludes this proof.